Yeah, let's go with the exercise 25. It says, ora prova tu. Una motocicletta di massa 200 kg, inizialmente ferma, P0 is equal to 0, raggiunge la velocità di 30 metri per secondo in 10 secondi. Quanto vale il modulo della forza che si è agito nell'intervallo di tempo considerato? Yeah, first of all, why there is a force? Like, okay, this chapter is about Newton and everything, but why there is a force? Well, let's draw again our car. Yeah, this is intuitive, but I need you to tell you that if this is fermo and you want to move it, you can imagine someone here pushing the car. And while he's pushing, his arms are getting bigger because it's applying a force. The force is what it produces the movement. If you see the other law of Newton, it says everybody stays like quiet, stop, unless an external body apply a force over them. It can be literally a body, or it can be detrito, or if this car is così, mira. How do I rotate it? No, I can rotate it. Sí que I can, aspetta, Well, if I could rotate it, that I can't. Imagine that you have a hill. If the hill is like this, then the gravity is going to make the car go down and like this. So the gravity is applying the force. That's the body that applies the force. In this case, let's say that is a person. And that is what is going to make the car move from 0 velocity per second, that is being in reposo, to a velocidad final is equal to 30 metros por segundo. Yeah? So it passes from 0 to 30, therefore something make it goes faster. Normally it's the motore. That's why it exists a force. Va bene. And what it says here, the velocidad final es 30. La velocidad inicial es 0. How much is the initial time? 0, because we have to define like that. And the final time, how much it took it to happen this? 10 seconds. Yeah? So al final, T0. And what we know, the acceleration is equal to la velocidad final menos la velocidad inicial, el tiempo final menos el tiempo inicial. Okay? And why we want the acceleration? Because they ask the force, and we know that the force is related by this. We have the mass. It's a motocicleta de masa de 200 kg, but we don't have the acceleration. But don't worry, we can calculate it. And by replacing, we have that the final velocity 30, the initial 0 because it's ferma, the final time 10 seconds, the initial times 0 seconds. So it's going to be equal 30 dividido 10 is equal to 3. So the acceleration is going to be equal 3 metros partido segundo al cuadrado. Now, if they ask the force and the modulo of the force in particular, the massa force is equal to the massa, that is 200 kg, multiplied by the acceleration, that is 3. And this is equal to 600 newtons. So first answer, F is equal to 600 newtons. Yeah? Let's see the second one. The second one says, ¿Quale distancia ha percorso la motocicletta nello stesso de tempo? Bueno, in the same that before, here we have a moto rectilíneo uniformemente acelerato, because it starts from 0 and the acceleration is constant in a defined time that is 10. So let's try the old trustable formula, that is S in function of the time is equal to S0 plus B0t plus 1 diviso 2 acceleration time to the square. Yeah, S0 is equal to 0, we define it like that. B0 is equal to 0 because it starts fermo. And how much is the time that this movement happened? It's 10 seconds. Yeah, so again, you can draw a line like this. This is 0, this is 10. Here, the velocity is 0, dopo the velocity is 1, the velocity is blah, 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 until you arrive here, that the velocity is going to be a value. Yeah, and here it it moved a certain amount of meters, and that's what we are going to use to calculate that. Okay, so replacing, we have 0 plus 0 per 10, that is going to be the second that we're going to use, plus 1 diviso 2. The acceleration, how much is? We just calculated 3 per 10 alla seconda. So it's equal to 0 plus 0 plus 3 diviso 2 per 10 alla seconda, that is 100. 3 dividido 2, no sé cuánto es, espérate. 3 dividido 2 es 1,5 más 1,5 por 100, that is equal to 150 metros. So the distance that it moved is equal to 150 meters. Yeah, let's make a resume pretty fast. First, la motocicleta inicialmente ferma, va a ser igual to 0. It increased from 0 to 30 the speed. So with that in mind, we say, let's calculate the acceleration, because the acceleration is the change of the speed in an interval of time. Here we have a change in the speed in an interval of time. So it's perfect for what we want to use. Okay, so also we have the motivation that we need to use this formula because that's the force, and you don't have any way to know the force. And that formula asks you the acceleration, and you don't have it yet, so you want to use it. We found the acceleration by subtracting the difference in the speed and dividing by the difference in the time. And that is going to give you 3 meters per second. Dopo, we replace in the second law of Newton, and it's going to give you how much was the force. E dopo, you have to recognize that you have a motor rettilineo uniformemente accelerato. So we use the good formula that never going to let you down, like Rick Astley. And we replace the numbers. S0 because you can always define as 0 if they don't tell you something. B0 is equal to 0 because it started fermo. And T is going to be equal to 10 because it's the espostamiento after 10 seconds. And that is the total time of movement. So it's literally what they are asking. How much it moved in 10 seconds is the same as asking which one is the position after 10 seconds. That's why we use this formula, and it gives us 150 meters. This is the 25. Yeah, now let's use another page to do the 26. Yeah, and it says un automobile della massa di 1200 kg che traina un rimorchio di 300 kg sta accelerando con una accelerazione costante di 0,5 metri per secondo. A un certo punto il rimorchio si stacca, mentre la forza del motore non cambia. ¿Cómo se modifica il moto della macchina? Yeah, va bene. For that, I will put the camera to explain you a little thing. If you have this and you pull it hard, but this is holding it doesn't move. But if I drop this goes away. Yeah, this is the remolque and this is automobile. So the remolque is pulling behind and this is moving, and this has to make a force to move it. So while this moving, it goes like this, and if the remolque goes away, what happens? This goes faster. So what we can expect, we expect that the acceleration increase, because if before I was doing this force, it was to move 2,000 kilograms, and if I suddenly lose 1,000 kilograms, then the acceleration, the force, if it's the same, the acceleration has to increase. It makes sense, no? If you are lighter and you are making the same force, then the acceleration has to be more. You move faster. That's the second law of Newton. So we come back to our paper. We come back here to our paper. And we're going to do the situation, as always. Yeah. First, we have automobile, auto, is equal to 1200 kilogramos. ¿Ya? El remorquio is equal to 300 kilogramos. The acceleration that is making in the beginning is equal to 0,5. Okay? It says that the fuerza de motores doesn't change after the remorquio goes away. So the force that is doing that now is the same force that's going to be when the remorquio is not. So let's calculate it. Again, the force is equal to the mass multiplied the acceleration. The force, we don't know it. The mass, how much is? This plus this, because you can think it as an only body. Like if this is the car, the máquina, yeah? And this is the remolque. No one cares if you do like this. Like all of this is one thing, it's the same, like for physics. So this is equal to this. The acceleration is 0,5. Then the final force is going to be this multiplication, that is 155 en 500 por 0,5, that is equal to 750 newtons. Yeah. And what we say, ancora, the force doesn't change. We lose the remorquio, therefore we are 300 kilograms lighter, but the force doesn't change. How much it changes acceleration? If we want the acceleration and we have the force and the mass, we can use the second law of Newton. So F2 is going to be equal to F1 because we say it doesn't change. But the mass, how much is now? Now it's not 1,500 because we lost 300 kilograms. Now it's only one, let's see. And acceleration is what we don't know. So we put it, how much was the force? If it doesn't change, it's 750. It's equal to 1200 por A. Yeah? So the force is the same, the mass is less, then the acceleration, what has to happen? I'm going to prove you mathematically. If this doesn't change, but this goes down, what this has to do? Goes up. Yeah? To keep the quality. Yeah? So we do like this. If we want the acceleration, then we do diviso 1200. So 750 diviso 1200 is equal to A. And if we do this is equal to 0,625. How much was in the beginning? 0,5. How much is in the end? 0,6. What it happened? It increased. To how much? To this. Yeah, so if you see here, it was very important, the intuition. But you can also do it like only reading the problem, because it says the acceleration, it says a un certo punto il rimorchio si stacca mentre la forza del motore non cambia. La forza no cambia. So the force in the beginning is the same as the force in the end. That's how you do essentially this. So, ¿cómo se modifica el motor de la máquina? Bueno, el motor de la máquina se modifica, that acceleration is equal to 0,6. Yeah. Let's do the 27. This one is interesting. Interesting. Yeah, let's read it. It says, Giada e Riccardo giocarono il tiro alla fune con un accordo di massa 0,75 kg che tiriamo in versi opposti. Giada tira con una fuerza de 16 newtons e la corda acelera verso Riccardo con una acelerazione di 1,25. ¿Con quale fuerza sta tirando Riccardo? Va bene. This is super interesting. Yeah, so we have Chiara here. así, with your skirt. The corda is here. No, così, because we're too lejitos. And this is me, with the corda here. Así. And the corda is moving here with acceleration of 1,25 meters per second to a square. Yeah, you are pulling back with 16 newtons, but the corda is still moving there. So what it means that my force is bigger than yours, of course. Like if the corda moves to me, then the force that I'm applying is more. Yeah, and how much is that force? Well, we can analyze what happened with the movement of the corda. Yeah, the corda is like this, and the opposite starts moving there with an acceleration equal to 1,25. Yeah, the masa is equal to 0,75 kilograms. Mass acceleration. What we can get with this? The force. What force? The force that is being applied in the corda. And what we know about the force and the movement. As I told you, everything stays fermo unless you apply a force. Yeah. Let me ask you a question. If you pulled like this with a force of 100 newtons, and you pull there with a force of 100 newtons, is going to move? No, because this is going to have, for example, a minus 100, and it's going to be this. So if we add the forces, it's going to be equal to 0, so there's no movement, because F is igual a M por A. If this is 0, and the mass is not 0, therefore the acceleration has to be 0. Yeah, so what is happening here? As I told you, I'm making a bigger strength, but what characteristic has this strength that is more than 16? But what happened if my strength was the same as 16? Then there's not going to be movement. So what that implies, that the movement that is over the corda is the difference between my force and 16. Like how much than 16 I'm making, because if I make less than 16, then the corda will move here because you're pulling stronger. If I make 16, the corda is going to stay firma because minus 16 and 16. Then the only chance left is that if the corda moves there, then you are making more than 16. And how much more? Well, that how much more is what makes this move. So let's calculate it. F is going to be equal to M per A. M, how much is? 0,75. The acceleration, how much is? 1,25. And if we put this into the calculator, it's going to give you 0,93. That means I'm 0,93 over your newtons. Then if your newtons are 16, I'm like this, therefore my strength is equal to this newtons. And what it says the book is this is 0.9 only. Yeah, this is very interesting because you have to analyze this. What if you make less than 16? Then the corda moves there. What if you make 16? There's no movement. What if you make more than 16? Well, then I'm stronger than you and the corda is going to move there. Therefore, the movement that is occurring here is only made by the difference of this. Because again, if it was the same, no. So if it's more, if it's 0,1 more, then I win. Certo? In this case, it's 0,9 more. Yeah, and that's exercise 27.